Relative to rationalizing denominators are these animals called conjugates. Do you remember that we decided that from now on, all radicals must be in numerators only? Okay, so that you could compare your answers. So everyone has come up with this convention so that no radicals will be allowed in denominators. Remember that. Now consider this problem. How can we rationalize this denominator? You might think, oh, well, I'll use my old trick of multiplying the top and bottom by whatever it takes to get rid of that radical, that square root of 5. Do the top and bottom, both because you're multiplying by 1. Now let's see what happens if we use our old trick. In the top, not too bad. We get 3 radical 5, and we're allowed to have a radical in the top. In the bottom, we may get radical 25, but we also, because there's a minus or a plus here, and we did get rid of the radical there. In this case, though, we also have to multiply the radical 5 by the number, and we haven't helped ourselves because we still have a radical in the denominator. Now, this is only going to occur when we have a plus or a minus in the denominator. So that's when we're going to have to use a new trick.
Oh, it didn't work.
Okay, but we'll have a new trick for you. Okay? The new trick is somewhat related to what we used to call FOIL. The nice thing about FOIL was we would take the first term and multiply it times both of them, and then we'd take the second term when we were done with the first and multiply him times both of them. And notice, in this case, when we added like terms, when we added a plus and a minus, we got rid of the middle terms. Okay, we're going to use that to our advantage.
Hey, man, check it out, huh?
But we have to have a plus and a minus to use this to our advantage. Pluses and minuses are another way of saying conjugates. Conjugates, basically, are twins, but they're an odd couple. They're twins with opposite signs. They're the odd couple. So, to rationalize the denominator using this conjugate idea, we're going to multiply the numerator and denominator by the conjugate. Okay, now certainly we have to do the top and bottom by the same thing, because if we do it by the same thing, okay, we're still using that trick. We're multiplying by 1. But recall what conjugates are. They're the odd couple. They're twins with opposite signs. And what's that going to buy me? Well, watch. Let me multiply and distribute the top. I'll get 3 radical 5 plus 6. Big deal. That's easy. In the bottom, I'm allowed to have radicals in the top. It's the bottom that I have to get the radicals out of. So, let's do the first term times both of them. That'll give me a radical 25, which is a 5. That cleans him up. And then I get radical 5 times 2, and that doesn't look good, except that recall that we're using a conjugate. We're done with this first term, and now we're going to do the opposite. And the minus 2 radical 5, that's where we're going to get rid of the radicals. Pretty good, huh? Has to be a conjugate. And then minus 2 times 2 is minus 4, and we have another clean number, if you would. And you have rationalized the bottom.
Genius. That's what it is. Sheer
And there's your answer.
Do that again.
Okay, let's rationalize this denominator using his conjugate. We're going to multiply top and bottom. Well, we started with a plus, so the conjugate will have a minus. Got to do top and bottom, okay? Because that's 1. Now, recall once again, we have to use a conjugate here because we have a positive or a negative. And the conjugate is the twin with an opposite sign. It's an odd couple. Now let's multiply everybody out, and we should be cleaning up the denominator. In the top, I get radical 3, 1 radical 3, minus 7. And that's okay.
No problemo.
I'm allowed to have a radical in the top. Now in the bottom, if I use the conjugate, I'll multiply radical 3 times each of these. That gives me a radical 9, but recall, that's a perfect square. And then I get minus 7 radical 3. And I'm going to get positive 7 radical 3. And the conjugate has taken care of everything, hasn't it? Don't forget the last multiplication. 7 times minus 7. And then add like terms. And I think you've got yourself an answer.
3 words. Fab, you love.
And that'll work every time. Now let me give you one last example. Now we're going to rationalize once again using a conjugate because we have a plus or a minus in the denominator. Can you think of what the conjugate's going to be in this case? It's always the opposite sign. Okay? Conjugates are twins with opposite signs. Okay, now let's multiply. 2 times 3 radical 2 is 6 radical 2. And 2 times minus 4 is minus 8. And we're good in the top. Now let's be careful in the bottom. First, let's multiply 3 radical 2 times both of these. I'm going to get 9 radical 4. But radical 4 is really 2. So I'm going to get an 18 for that mix. Now, let's multiply 3 radical 2 times minus 4. And we have a little bit of bad news because we have a radical temporarily. Now let's use the power of the conjugate and multiply the 4 by 3 radical 2. And of course, that's why we did the conjugate.
I'm dangerous. I'm very, very dangerous.
It'll get rid of it, won't it? Okay. And finally, 4 times minus 4 is minus 16.
Is that your final answer?
Well, we're still required to simplify, okay?
Don't make me angry. You wouldn't like me when I'm...
Don't ever cancel it, since there's always going to be additions in these problems, isn't there? Let's remember, one of the more common mistakes, don't ever cancel things that are added or subtracted. So we can't do that. We have to factor first. Let's factor. Look at the top. Notice that a 2 comes out of both of those terms. Okay? Take a 2 out of 6 radical 2 and you get 3 radical 2. Take a 2 out of 8 and you get 4. Now you can cancel, because you can cancel things that are multiplied. You just can't cancel things that are added. And I believe
You've done it again.
we've got an answer. Okay, that's about as hard as it'll get. So, you're going to need to practice. Get off and go to work.